Honors Algebra 2, Chapter 6, Section 4, Inverse Functions. So we're going to look at how to graph and find the equations of inverse functions. So inverse functions is when two functions are inverses, when their domain becomes the range and the range becomes the domain. So recall what domain and range mean. The domain stands for the x values, the range stands for the y. So the x's and the y's basically switch spots, and that's what a function does. It undoes itself. To find the inverses, these are the steps you want to go through for finding inverses. You need to switch the x and y, and that's just the definition. The x becomes the y becomes the x. You switch the domain range. After you've done that, you still want to solve for y or isolate y, and then we call the result f to the negative 1. That's the inverse function. So you have f of x, we have f to the negative 1 as the inverse function. And so here, for example, we can take and switch our y and our x. Remember, f of x is really y. So we're going to put the x in place of that, and then put y in place of x. And then now we need to solve for y. So subtract 6 to both sides. Then I can say I'm going to multiply both sides by negative 1/3, the reciprocal of both sides. So I have negative 1/3 x plus 2 equals y. And so this is the inverse function. So I could write that as f to the negative 1 equals negative 1/3 x plus 2. And so because I say f to the negative 1 is the inverse of f, so then I know that the function f and the inverse function will undo each other. So I take some value, let's say I take the number 2, and I put it into the function 2. I get negative 6 plus 6, or 0. So let's take that 0, the answer, and plug it back in here. So we plug that 0 back into the inverse. 0 times negative 1/3 is 0. 0 plus 2 is 2. So it undoes it. It goes back to where we started. That's the whole point of the inverse function. It undoes what we're doing. So for tables, if we had this original table, so the x values are negative 2, negative 1, 0, 1, 2. These are also called the domain. And then the f of x, which is are the y values or the range. So if you're finding the inverse function, we are taking the x values, and those become the y, and the y values become the x, and so they just flip spots. And so the x, which was the x, now becomes the y. And so we can note that as we now have x and the inverse of f. So the graph, we can look at these graphs. So if we give this function, what we're doing to find the inverse of f of x is it's a reflection. It's a reflection over this line. So this line, if we flip the red graph over the blue line, you'll get the inverse function. Another way to do it to be more accurate, a lot of times I'll take a point. This point here is 2, negative 1. And then what happens is they flip spots. It becomes negative 1, 2. This point here is 4, negative 2. It's going to become 2, 4. This point here is negative 2, 1. It's going to be 1, negative 2. And then this point over here is negative 4, 2. Is 2, negative 4. And so this would be the equation of the inverse, the graph of the inverse. So if you see the red line, you flip it over the blue dotted line, you'll get the black line. So the black line is actually the inverse of f. So inverses are reflections of f of x over the y equals x line. So we'll say y equals x reflection. So equations here, we can find the inverse here, another example. So we switch x and y, and then we solve for y. So x plus 3 equals 6y, and then y is going to be 6x plus 1/2. And we could write that as the inverse of f is 6x plus 1/2. And so if we have g of x here, we can find the inverse of g by, again, just switching. And then solve for y, so multiply both sides by 3. Easy peasy. So f is an inverse of the function of f if and only if the composition of the two equals x, and it's got to go both ways. So the f of g of x is x, and that's critical here, and g of f of x is x. And so if you show the composition both ways, this is the proof to show that two things are inverses. So the key word here, if I say verify, verify is a key word. Whenever you see the word verify, you have to show the compositions are true. So I'm giving the f of x is 7x, the inverse is 1/7 x. To verify, we need to do both the f of the inverse of f of x and the inverse of f of x is x. So that both of these are going to be equivalent to x. So if I take the first one, let's do f of the inverse of x. So to do that, I'm taking the function of f of x, which is 7 times x, and I'm replacing x with the inverse of x. So it's 1/7 x. And if I multiply 7 times 1/7, I get 1 times x, or x. So that works. Then I need to do the inverse of f times f of x. And for this one, it's going to be 1/7 times x, and x here is 7x. So if I multiply that, I get x again. So because both of those equal x, that verifies that those two things are inverses. So vertical line test. So we've looked at the vertical line. This red parabola is a function because it passes the vertical line test. Well, there's another one called the horizontal line test. And the horizontal line test tells us if the inverse is a function. So the horizontal line tells us if the inverse graph is a function. So because I can draw a horizontal line here through 2 points, then the inverse will not be a function. And to find the inverse graph, I can show you that by looking at some points here. So this point right here, 0, -3, is going to become -3, 0. If I look at the intercepts, this intercept here is 2, 0, it's going to become 0, 2. This one here is -2, 0, it's going to become 0, -2. So I'm going to get this shape, which you can see is not a function. It doesn't pass the vertical line test. So what we will do sometimes is we'll actually restrict it and say we're not going to look at all of it. We'll only look at that portion. And so we can restrict the domain of f of x, so the inverse of f of x could be a function. So I want to do one more. I want you to verify that f of x equals 1/2 x minus 3, and inverse of f of x, which is going to equal 2x plus 6, are inverses. So verify that those are inverses of each other. And this is going to be your homework problem to turn in when you walk in. So that's it. Have a good night.